Aloha, my name is Robert, and welcome back to Neapapakahana Online Professional Development for the Canoe project. Today we'll be going over Module 9 of 15. Just like before, we begin by going onto our website, www.stemd2.com. After you've logged in, let's go ahead and go on to Students, and let's build a canoe. Today we'll be covering Module 9, which is in Unit 4 of the Go Math book. So let's go down to Unit 4. Here we can read the introduction to Unit 4 and watch the accompanying video. Or we can go ahead and go straight into Module 9. Here are the list of activities for Module 9, which is about transformations and congruence. The first activity that we'll be discussing is Canoe 9.2.1. This is the activity that corresponds to Lesson 9.2 in the Go Math book. In this activity, we will need graphing paper and a ruler. The ancient Hawaiians flew kites for fun and for fishing, but in order to fly straight, it is important for the kite's shape to be symmetric. In this activity, we will take a shape like this, and then we will reflect it to create a line of symmetry. And this will allow us to make a kite. So for example, we start off with 4 points that create this shape. And then we reflect these 4 points about the vertical line x equals 0 to get the following kite. In the first question, we will go back to these 4 points, and then we will reflect them about the horizontal line y equals 0. And then we will write down the new points. Whenever we reflect a point about y equals 0, what we are actually doing is changing the sign of the vertical component. So the new point A will change from 2, 0 to 2, 0. The point B will change from negative 3, 1 to negative 3, negative 1. The point C will change from negative 5, negative 3 to negative 5, positive 3, and so on and so forth. In the next question, we ask the students to use graph paper and the new points to create a new kite. Finally, we have one more kite that is created by taking the original shape and using a new line of symmetry. The line of symmetry is a diagonal line that goes through here. And what we need in this question is the equation for this line. Now that we have 3 different kites, we want to compare the designs. This is an open-ended question where we ask the students to choose one of the 3 designs and explain why they like that design the best. Next, we have a pretty difficult question. We want the students to try to figure out, how does a kite fly? We do not need the students to be experts in aerospace engineering, but we do want them to do some research on their own and come up with some hypotheses. And then we want the students to share their ideas in the comments section below. Finally, we conclude this activity by asking the students to design a kite of their own. We want the students to create a shape and then reflect it to make it symmetric, and then use that reflection to create their kite. That's it for this activity. Please pause the video and take some time to review and reflect on it. Let us know how you can use this activity in your classroom. In particular, we are very interested in learning how you can incorporate research and kite building in your classroom. Hey, welcome back. The next activity that we'll be talking about is Canoe 9.3.1. In this activity, we will be learning about Chief Meli, who is in love with the princess of Manu Island. To impress her, he paddles in a flower pattern with her island at the center. So he starts at her island, then goes out to form petal A, then back to the island, go out to petal B, to the island, petal C, to the island, to petal D, and back to her island. Unfortunately, Chief Meli was daydreaming, and he accidentally went to the wrong island. So instead of making a flower pattern here, he made a flower pattern up here around Mano Island. In this activity, we will talk about how Chief Melly can move the flower from here to here using translations or rotations. We will also take a look at these 4 points, A, B, C, and D, and we will talk about the new locations after being moved by translations and rotations. In particular, we want to know whether the orientation of these 4 points have been conserved, and what are the consequences. That's it for this activity. Please go ahead and pause the video and take some time to review and reflect on it. Aloha, welcome back. Let's go on to our final activity, Canoe 9.4.1. The Canoe brothers have a strategy for catching fish. First, they use their canoes to chase the fish and bring them together, and then they form a triangle and throw their nets into the triangle. In this activity, we will be learning about the mathematics involved in moving a shape like a triangle. In this example, let's think about how we can move this triangle from here to here. One way to do this is by rotating the points of this triangle 90 degrees clockwise about the origin, and then translating these points 1 unit to the left. This is because the original vertical component becomes the new horizontal component. Also, the horizontal component becomes negative of the new vertical component. Next, we translate the triangle 1 unit to the left. So to the horizontal component, we subtract 1. Please go ahead and pause the video and check my work if you'd like to. Another way we can move this triangle from here to here is by translating it down first and then rotating it 90 degrees clockwise about the origin. So if we start off with points x, y, after we translate these points down 1 unit, we have x, y minus 1. And then when we do a 90-degree clockwise rotation, we have y minus 1, negative x. Once again, this is because in a 90 degrees clockwise rotation, the vertical component becomes the new horizontal component, and the horizontal component becomes the negative of the new vertical component. By doing this, we can see that every point xy on the old triangle is now moved to the point y minus 1, negative x on the new triangle. In this activity, we will replicate these steps in order to figure out how to move these points from here to here and from here to here. Finally, we want to acknowledge that the way the Go Math book does this is very different from the way that we do it. In the Go Math book, students are asked to write expressions for each step. So you have an expression from here to here and another expression from here to here. The way we do it is we want one expression that takes us from the beginning all the way to the end. Typically, the Go Math book is a little bit easier because we just take things one step at a time. The way we do it is a little bit harder because we accumulate changes from the beginning all the way to the end. Although our way is a little bit harder, we hope the students see the benefit. For example, students can use our expressions to go from the original point all the way to the final point, skipping the points in between. Furthermore, our expressions can be used to check the work. As you can see here, we have 2 sequences of transformations, but we are starting with the same original shape and we are ending with the same final shape, so we should have the same expressions. And as you can see here, we do. So this is a way of checking whether 2 sequences of transformations are equivalent. That's it for this activity. Please go ahead and pause the video and take some time to review and reflect on it. Let us know how you can use this activity in your classroom. Alright, that's it for Module 9. We'll see you again for Module 10.